Hi, math enthusiast. I would like to invite you to join us and be a member of e-DEOlogy community. If you become a member, you will help e-DEOlogy YouTube channel to make more math videos and to ease logistics expenses. See you all in e-DEOlogy community and get this beautiful e-DEOlogy fun badge and be a member according to your interest as a bronze member, a silver member, or a gold member. We love to see you in e-DEOlogy community. Hi everyone. In this video, we are going to study basic concepts of probability. Let us define probability. Probability is a measure that is associated with how certain we are of outcomes of a particular experiment or activity. An experiment is a planned operation carried out under controlled conditions. Random experiment is an act whose outcome cannot be predicted with certainty. For example, tossing of a coin is a random experiment. Though we know that the outcome of the experiment will result either head up or tail up, we cannot certain what it will be. Other examples of random experiments are rolling a dice and football game. A result of an experiment is called an outcome. An event is any combination of outcomes. Uppercase letters like A and B represent events. For example, if the experiment is to flip one fair coin, event A might be getting at most one head. The probability of an event A is written P of A. Another example, in the random experiment of rolling a die, coming of one is an event. Coming of two is the other event. And coming of even number is another event. The first two events are called simple events because they correspond to only single outcome. Coming of an even number is called a compound event because it corresponds to more than one outcome of the experiment, namely 2, 4, and 6. We can combine events to form new events using the various set operation. The first one is A, U, B, and this is read as A union B. A union B is the event that occurs if and only if A occurs or B occurs or both. This is sometimes called OR event. For example, let event A, whose outcomes are 1, 2, 3, 4, and 5. And event B, whose outcomes are 4, 5, 6, 7, and 8. A union B equals 1, 2, 3, 4, 5, 6, 7, and 8. Notice that 4 and 5 are not listed twice. The second operation is A inverted U B. This is read as A intersect B. A intersect B is the event that occurs if and only if A occurs and B occurs. Sometimes this is called AND event. For example, let A be an event whose outcomes are 1, 2, 3, 4, and 5. And event B whose outcomes are 4, 5, 6, 7, and 8. A intersect B equals 4 and 5. And these are the outcomes that are common to event A and event B. The third is A complement, and we read this as complement of A. This is the event that occurs if and only if A does not occur. Sometimes this is denoted by A apostrophe and read as A prime. For example, let S be an event whose outcomes are 1, 2, 3, 4, 5, and 6. And let A be a subset of this set S, and the elements of event A are 1, 2, 3, and 4. A complement is an event whose elements are 5 and 6. This A complement has elements of set S that are not element of set A. The sample space of an experiment is the set of all possible outcomes and is denoted by S. Examples: number 1, in tossing a fair coin, the sample space is S equals H and T, where H equals head and T equals tail are the outcomes. Example 2, in tossing two fair coins, the sample space is S equals HH, HT, TH, and TT. Example 3, in rolling a die, the sample space is S equals 1, 2, 3, 4, 5, and 6. In throwing two dice, the sample space is given here. The sample space starts with 1, 1 and ends up into 6, 6. Example 5, in a pack of cards, there are 4 suits, which are hearts, clubs, diamonds, and spades, and 13 cards for each suit, that is, from ace through king. There are 52 outcomes in the sample space. Each element of sample space is called sample point. Example, in rolling a die, sample space S equals 1, 2, 3, 4, 5, and 6. Number 4, that is the number 4, is a sample point. Let us define equally likely experiment. Equally likely means that each outcome of an experiment occurs with equal probability. Example, if you toss a fair coin, a head and a tail are equally likely to occur. Let us define mutually exclusive events. A and B are mutually exclusive events if they cannot occur at the same time. This means that A and B do not share any outcomes. Example, let event A has elements small a, small b, and small c. Let event B, whose outcomes are 2, 4, and 6. We say that A and B are mutually exclusive events such that A intersect B equals 0. Hi everyone. Today we're going to study empirical probability. Let us define empirical probability. Empirical probability uses the number of occurrences of a given outcome within a sample set as a basis for determining the probability of that outcome occurring again. The empirical probability that an event A will occur is given by this formula. P of A equals number of times event A occurs all over total number of trials. Let us see example 1. You flipped a coin 100 times. It was recorded that 53 heads turned up. What is the empirical probability of getting a head? For our solution, let us write our formula. P of A equals number of times head occurs all over total number of trials. So our answer is 53 over 100. This is the final answer. Example 2. A class has 25 students. One student is absent today. If 19 students turned in their homework today, what is the empirical probability that the absent student will submit his homework when he returns? For our solution, let us write our formula. This is equal to number of students who submitted homework all over total number of students present on that day. This is equal to there are 19 students who submitted their homework all over. There are 24 students present on that day. So our answer, 19 over 24. This is the final answer. I hope you learned something from this video. See you again next time. Let us now study probability of an event. In particular, we will have probability of an event E. Assume that an event E can occur in R ways out of a sum of n probable or possible equally likely ways. Then the probability of happening of the event or its success is expressed as P of E equals the fraction R over N. There are notes here that we need to know. For a sample space S and an outcome A of S, the following two properties are satisfied. The first one, the probability of A, denoted by P of A, is between 0 and 1 inclusive. In the books, you will see the symbol which means this is statement 1. Number 2, the sum of the probabilities of all the outcomes in S equals 1. In symbol, you will see this formula in some statistics books. Let us see some examples. If two dice, one red and one green, are rolled, find the probability that the red die shows a number 3 and the green shows a number 6. For our solution, we will write our table, and since two dice are rolled, there will be 36 possibilities as shown on our table here. Then the 36 is here. Since 36 is one such outcome, the probability of obtaining 36, which means again 3 for the red die and 6 for the green die, is 1 over 36. This is our final answer. Example 2. If two dice are rolled, find the probability that the sum of the faces of the dice is 7. Now, let us borrow the same table from our example 1. For the solution, we let E represent the event that the sum of the faces of two dice is 7. Since the possible cases for the sum to be 7 are E equals 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Therefore, the probability of the event E is equal to P of E equals the fraction where the numerator is n of E, which means the number of outcomes in E over the denominator n of s, which means the number of outcomes in the sample space. So we have here 6 over 36, and this can be reduced as 1 over 6. This is now our final answer. Let us see example 3. A jar contains 3 marbles numbered 1, 2, and 3. If 2 marbles are drawn, what is the probability that the sum of the numbers is 4? For the solution, since 2 marbles are drawn, the sample space consists of the following 6 possibilities. S equals 1, 2, 1, 3, 2, 3, 2, 1, 3, 1, and 3, 2. Let the event E represent that the sum of the numbers is 4. Then, out of the sample space, E equals 1, 3 and 3, 1. Therefore, the probability of E is P of E equals the n of E over n of S. And this is equal to 2 in the numerator because there are 2 outcomes in the E over 6 because there are 6 elements in our sample space. We can reduce this to lowest term, and this is equal to 1 over 3. This is our final answer. Let us see example 4. Suppose a jar contains 3 red and 4 white marbles. If 2 marbles are drawn, find the following probabilities using a tree diagram. Letter A, the probability that both marbles are red. Letter B, the probability that the first marble is red and the second is white. For our solution, let R be the event that the marble drawn is red, and let W be the event that the marble drawn is white. Now, this is the tree diagram. This point here is the root, and there are 2 branches. At the end of this branch is R, and the other is W. These 2 branches here represents the first draw, which means the probability of taking R or red marble is 3 over 7. While for the white marble, the probability is 4 over 7. Now, on the next branches here, these branches represents the second draw. From the R here, there are 2 branches, and this branch represents drawing another red, and the probability is 2 over 6. Now this W is the event of drawing a white marble, and the probability is 4 over 6. Down here is another pair of R and W. This branch here represents the probability of taking a red marble, and the probability is 3 over 6. And down here is the event W, which means taking a white marble, and the probability is 3 over 6. Now, let us compute for the probability here of taking 2 red marbles, and that is, we simply multiply the probabilities as shown in here. So 3 over 7 multiplied by 2 over 6, the answer is 6 over 42. This RW here means taking red marble in the first draw and white marble in the second draw. And that is, we will multiply the probabilities as per our tree diagram. So we have 3 over 7 times 4 over 6, we will get 12 over 42. And down here is WR, which represents taking white marble in the first draw and red marble in the second draw. And the probability is the 4 over 7 times 3 over 6. And we have here 12 over 42. And this WW means taking 2 white marbles for our problem. So we have this 4 over 7 times 3 over 6. And we have here 12 over 42. Now, to answer our problem, letter A, the probability that both marbles are red, which means we will have the P of RR. And this is equal to this value 6 over 42. Let us simplify this in lowest term. We will have 1 over 7. Next, for letter B, the probability that the first marble is red and the second white. So we have the P of RW. And this is our answer, the 12 over 42. Let us reduce this to lowest term, dividing by 6 the numerator and the denominator, and the answer will be 2 over 7. So this is our final answer. I hope you learned something from this video. See you again next time.